Inside of this box you can find almost 1,000 parts, and all of them are made out of metal. And when you put them together, you'll get this. This is model of jet engine, and in today's video I'll show you how to assemble it, what everything you'll find in the box, how close it is to real engine, and how jet engine works. So let's start. This video is brought to you by Sterling Kit. More about them in the description below. Manufacturer calls this engine DM119, but when you open the manual, you can find their reference to Airbus A320, Boeing 737 and COMAC C919. And basically they're saying that this should be engine for passenger airplanes. On the picture you can see Boeing 787 and it has for sure no connection. And when we try to find the closest match to what informations we get, we can assume that, let's say this is copy of LEAP 1 and A320 has LEAP 1A, Boeing 737 MAX has LEAP 1B, and COMAC C919 has LEAP 1C. And basically bigger cousin of LEAP 1 is GEnx. So in the end we can say that this is true. Okay, this is just for beginning to give you an idea what you can find in the manual. In the next few steps, I'll always try to refer it to real engine. In this case, I chose that LEAP 1, and from that point we will always compare how close this model is to real engine. So let's continue with unboxing. Box is huge and of course it's heavy as well. Each section is marked, so you have a number inside, and whenever you will start to assembly in the manual you will find the number of the section, and thanks to this phone number you will know exactly which part you should pick up. And just to give you an idea how big it will be, this is part of the fan case, so it will be pretty big. All the way on the bottom you can find, I guess, all the tools which we're gonna need for assembly of this engine model. So let's see. Okay, let's start with build up. First I need to put together all main components, and as a first I need to put together N1 shaft with a fan disc, and through this N1 shaft the fan itself is powered from the low pressure turbine, but to that we'll get a little bit later on. When fan disc is assembled we can start with installation of the fan blades, and they're again made out of metal. The installation is quite easy, the problem is with the spacers in between. It is similar to install fan blades on Boeing 737 NG. If you ever installed those fan blades, you know that these spacers are sometimes hard to install. A difference is on this model is that these spacers are secured from the back with the screws. This in the real world will cause a lot of problems because from time to time you need to remove the fan blades, and if it will be installed like this you need to remove the whole N1 shaft, which will cause a lot of problems. As you can see, fan blades are on the place, and I would like to mention one more important thing which we need to keep in mind during installation of the blades on the normal engine. Normally when you're installing the blades you need to mark each and every blade which you install on the fan disc. The reason behind is that every blade have a different weight, and if you assemble them in different pattern you can cause the vibration on N1 shaft, so they always need to be installed on the same position, and as well most of the time it is on the cone. You have their balancing screws. I showed to you on one of my previous video with CFM engine. Difference really is that here you need to install the blades in exact pattern. Now what we need to do actually is install this cone, or As a next, we need to assemble the first stage of a low pressure compressor. I already put two parts together, and now we need to slide the blades in. Actually, they look really cool. As you can see, they have nice dovetail on the bottom through which it locks on the place. Tied the ring all the way, and now we just need to slide blades one by one on the ring. And meanwhile, I'm putting this two-stage low-pressure compressor together. I'll try to explain how a low-pressure compressor works. It serves several purposes. First one is pre-compression of the air. The low-pressure compressor raises the pressure of the incoming air from the engine inlet before it reaches the high-pressure compressor. This initial compression reduces the workload of the high-pressure compressor, allowing it for more efficient overall compression. And as well, it optimizes the engine efficiency by dividing the compression process into the low pressure and high pressure compressor, to which we get a little bit later. The low pressure enables the engine to achieve higher overall pressure ratio without excessive stress on a single compressor stage. This division improves the efficiency and reduces engine losses. And again, we can compare it to LEAP-1A, which has 3 stages, and this engine has only 2. But it is interesting how much effort manufacturer put into details, because the blades and vanes looks really amazing. Problem is that whenever you assemble the engine, you will have almost no chance to see the low pressure compressor because it is inside. Okay, booster or low pressure compressor parts are almost finished, and now we'll move to the high pressure compressor and of course its case. And again, during assembly, I'll try to give you few informations about this component. High pressure compressor compresses the incoming air from the low pressure compressor to a much higher pressure, achieving pressure ratio, and this is exactly for LEAP-1, approximately 22:1, which means that if the pressure on the intake is 14.7 psi, which is ambient pressure at the sea level, on exit from the high pressure compressor we'll get around 320 psi. And this compression of the air will create another effect, which is a reduction of the speed. And again, let's take a look on an example. If we are in the cruise, the speed of A320 is around 830 kilometers. But thanks to this compression on the exit from the high pressure turbine, the speed of the air will be between 140 to 300 kilometers per hour. This high compression and slower speed ensure efficiency mixing of the air and the fuel for optimal combustion. And since we're talking about combustion, I already start to assemble combustion chamber. And exactly here the fuel is sprayed thanks to fuel nozzles, and it is mixed with air, and then it burns to produce the energy that powers the aircraft. Think of it as a heart of the engine where the real action happens. And on this model we can find example of annular combustion chamber. And what does it mean annular? It means it forms a continuous ring around the engine core. This design improves efficiency by providing uniform temperature distribution and better fuel mixing. And I finish outer shelf of combustion chamber, so let me show you a few details. This is our 4-stage high pressure compressor, which is in the LEAP version. This have actually 10 stages, which, as I mentioned before, reduce stress and create better compression of the air. This air will then lead here into the combustion chamber, where actually you will see later on fuel nozzles. Fuel nozzles are getting inside, and of course somewhere around, if it is LEAP, it will be down here, you will find 2 igniter plugs. Those igniter plugs during startup procedure will ignite the mixture of the fuel and air, and from that point it will burn and it will create the energy. We can take a look further on the combustion chamber itself. The fuel nozzles are inputted over here and air flow inside through these holes. That was a few more information about the high pressure compressor and combustion chamber. Now we'll put it together. Of course, I'll input the nozzles and Then we will continue to the next part, of course. As a first, we need to assemble high pressure compressor, and it is made out of rotor and high pressure lower stator case and upper stator case. And the same way are designed normal engines, because from time to time there is necessary to make some repairs on the blades of the high pressure compressor. And this case, when we remove just the top case, we can work on these blades without disassembling the engine. Compressor and combustion chamber has been assembled. Now I can focus on fuel nozzles. We need to install 12 of them, and of course fuel line which feeds these fuel nozzles. And whenever that is done, we need to assemble high pressure compressor with the combustion chamber. Now we can move to high pressure turbine. In this case we have only one stage. On LEAP 1A we'll have 2 stages of high pressure turbine. What is quite interesting to mention on high pressure turbine, that it need to withstand huge temperatures. What does it mean? In the combustion chamber you can have temperature from 1500 to 2000 degrees, and most of the metals will gonna melt during this temperature, and for that reason the blades of the turbine and the stator vanes are cooled. In this case, I'm not sure from which stage it will be here, but in ZFM LEAP 1, the cooling air is coming from the 7th stage of a high pressure compressor. So that air leads towards the outer rim, and it is sprayed inside of the blades or inside of the vanes, and the blades are cooled from the bottom. So this way the blades can survive such a heat. Before I'll put the ring on it, so I'll close it, I would like to show you this. Actually, this is quite interesting because the blades on the high pressure turbine looks basically the same. It have this like tree slot with which it holds on position, exactly like this it holds on the normal engine. So this is what I want to show you before I'll put this ring on. So let's do that. And now, what is the high pressure turbine good for? Well, it is the first turbine in the engine after combustion chamber. Its job is to extract energy from the super hot, fast moving air that comes out of the combustion chamber. This harvested energy turbine used to drive the high pressure compressor at the front of the engine, ensuring air keep flowing and get compressed for the combustion. And we can look at it as a power generator that keeps the engine cycle going. And as I mentioned before, this model has single stage high pressure turbine, but amount of the turbine depends on the power which we need to harvest for compressor. If the compressor has a lower pressure ratio, we need only one turbine. If it has higher pressure ratio, we need of course higher number of the turbines to harvest enough power. And from high pressure turbine I slowly move to low pressure turbine, and on this model we can find 2 stages, which means that we need to assemble 2 blade discs and the case with the 2 sets of the stator vanes. And again, I'm really happy how much effort manufacturer put into details of those discs and of course case itself. And luckily this part you are able to see because they are cutouts in the case. And again, let me tell you a bit about the low pressure turbine. What is it good for? Well, it sits behind a high pressure turbine and it has slightly different job. It captures leftover energy from the air and it uses it to drive the big fan at the front of the engine and of course low pressure compressor. That fan is what creates most of the thrust to push the airplane forward, and on these high bypass engines like these models it can create up to 70% of the thrust. So you can imagine how much power this low pressure turbine need to harvest. And since I'm almost done, I'll try to explain a bit more on assemble part. Here you can see our 2-stage low pressure turbine, which will drives the fan, and 2-stage low pressure compressor. On the CFM LEAP, this low pressure turbine combines 7 stages. And why 7 stages? The reason behind is that the newer engines or newer fans have a bigger diameter to move a bigger portion of the air. And of course, we're trying to slow down the fan. So the blades are bigger, but the fan is rotating much slower. The reason behind is to reduce the noise which the fan produce. And because we are slowing down the fan and it's still bigger and bigger, we need to somehow provide enough power to drive the fan and the low pressure compressor. And since we want to use a lower speed, we need to use more stages to consume enough energy from the hot gases to propel fan and the low pressure compressor. So that's why we need to have more and more stages. And since we know that, we can proceed with connection of high pressure section with the low pressure turbine. So now we need to place high pressure turbine on the combustion chamber. Then we need to put spacer in between high pressure turbine and the low pressure turbine. And after that, we can start to assemble it. And that means a lot of screws. And to be honest, this part, when you need to input bolts and the nuts on the whole circumference and tie them, is one of the most time consuming, but it needs to be done. And at this point, I'm starting to assemble one very important part and quite interesting. So I would like to mention it for sure. And that is called low pressure turbine active clearance control. The LPTACC is the smart technology that helps keep engine working more efficient by keeping the turbine blades at just right distance from their casing during flight. So imagine this, think of the spinning fan inside the tube. If the fan blades are too far from the tube wall, air leak around them, wasting the energy. But if the blades are too close, they might scrape the wall, which could damage the fan. The active clearance control system is like thermostat for the engine. It keeps the gap called the blade clearance just right, no matter temperature or speed. But how it works in reality? These little tubes which you see me installing on this model has holes on the inner surface. During normal engine operations, we supply these tubes with a colder air from the engine, and this air is then sprayed through these holes on the casing of the low pressure turbine. And thanks to this system, we can keep high efficiency of the engine. As next, we need to assemble turbine rear frame, and it is important structural component located at back of the turbine section. And on the TRF, you can find aft engine mounts through which it holds on the engine pylon. And from the back, we need to move all the way to the front because I need to assemble fan case. And actually here we can find few very interesting components, like first stage of the low pressure stator vanes and of course outlet guide vanes. And since on this section I need to install a lot of screws and nuts, let me tell you a few information about outlet guide vanes. OGVs are stationary blades located behind the fan in the engine. They have crucial role in the margin airflow because after air passes through the fan, it swirls because of the fan blade rotation. OGV straighten this swirling airflow, turning it into the smooth axial flow that efficiently enter into the engine core or bypass duct. On some type of the engines, it also maintains structural integrity, but on this engine we have for that intermediate case, but to that we'll get a little bit later on. Because now we can finally put together fan and booster or low pressure compressor. And as I mentioned before, it is completely hidden inside of the fan case, even though there is a lot of nice details. But I enjoy to assemble it, and for sure you will enjoy it as well. Now I need to assemble inlet gearbox, which is actually part of intermediate case, which is made out of several gears, and later on we will connect it with a shaft to transfer gearbox. Next item is intermediate case, which play quite crucial role in this model because it has structural function, because it needs to carry weight of the fan case and of course gearbox. And through one of its struts we are transferring transferring the power from the gearbox to N2 shaft and vice versa, but I will show you in detail. Before we continue further, I would like to show you this. Basically, this will be our transfer gearbox, which will transfer movement from the gearbox towards N2 shaft and vice versa from the N2 shaft towards gearbox. So during startup, the gearbox or starter through the gearbox will gonna drive N2 shaft, which you can see now, and during normal operations, N2 shaft will gonna drive the gearbox. This is actually standard thing. This is what you can find on the jet engine. Now I need to install also this part. This is not really a standard thing because since this is model, we somehow need to drive N1 shaft, and for that we're gonna use this gear. On the normal engine, as I explained before, N1 shaft is driven through the exhaust gases which propel low pressure turbine, and that one will rotate the fan and low pressure compressor. But of course we will not be able to produce such a power of N2, so we need to somehow drive the N1 shaft, and for that we're gonna use this gear. So let's continue further. And I'll continue with installation of the bearing inside of intermediate case, which will gonna support the N1 shaft, and then we can connect intermediate case with a fan case, and actually this is the last time when you can see low pressure compressor. And whenever markings on both cases are aligned, I'll install bolts and nuts on the whole circumference. And of course this is really time consuming because the nuts are really small, and on the whole circumference you can find 25 of them. Before we continue and we put the core section with the fan frame together, I would like to show you one more thing. On the normal engine, directly behind low pressure compressor, you can find something what is called bleed valves or variable bleed valves. Those valves prevent engine stall or surge. And how that works, during low speed operations, the booster or low pressure compressor can create too much air, and high pressure compressor probably will not be able to process that air. So in that case, those valves will gonna open, and that air which normally will flow into the high pressure compressor will be redirected out into the outer flow, and this way will prevent damage of the engine. But of course I explained it before, and one of my previous videos you will find it over here. But yeah, that's what I want to show you before I will put it together. So this is how it looks, and now we'll stick it together. And again, you can find in the manual quite clear instructions how to align those two parts. And whenever you do that, you just need to install few screws on the circumference. And for installation of those bolts, I recommend to use L-shaped Allen key because you don't have straight access to those bolts. So this is just little advice. Then I'll continue with TRF, and again before we need to install bearing which will support N1 shaft, and whenever TRF is aligned we need to again install all the bolts and the nuts on the whole circumference. And whenever this is done we need to secure N1 shaft on the place, and we need to try the rotation of the engine, and of course operation should be really smooth. Now we need to install center body, and it's made out of two cones, inner and outer, and inner one is a bit harder to install. I recommend to put bolts first in it and then try to install it. And then we need to install outer cone, and that one is quite easy because the screws are on the outer surface. And as last we need to install core nozzle, and again on this one we can find a lot of screws and the nuts, so again bit time consuming. And now we'll move to another interesting part, which is gearbox. And this was clever design how to hide a DC motor with which we're gonna drive the engine. Inside we can find several gears, which will change the gear ratio, which will reduce the stress from the electric motor. And as well we can find their clutch, with which we can deactivate the connection between model and electric motor, and it will allow us to rotate the N1 shaft freely without the resistance of the DC motor. And on the outer surface you can find also a few nice details like oil pump or fuel pump, and also filter assemblies. This again shows how much manufacturers care about little details. And of course, whenever gearbox is finished, I need to plug it to control box and test it if everything runs smooth as it should. And whenever test is done, I'll install accessory gearbox on transfer gearbox, through which, as I explained before, will transfer the power from the accessory gearbox to N2 shaft and vice versa. And as a next step, we need to assemble the base on which the engine will gonna rest, and there we can find also the control box, with which we're gonna control and supply DC motor, which we can find in the gearbox. And if we compare it to engine assembly, this is quite easy and quick task. And since I'm almost finished, we can install the engine inside of the base assembly. Okay, aft section is more or less attached. Now, the front, yes. Now it sits. Wow. Okay, it is on the stand. Well, let's engage the cable. I'll turn it to your side so you can see. And it works. Perfect. And since everything works as it should, we can install few final pieces, which is, for example, EEC, which is basically brain of the engine, and oil tank. And installation is pretty easy. EEC holds on 4 bolts and 4 nuts, and oil tank holds on 2 bolts and 2 nuts. And now we're getting to the point where it has something in common with the Gen X, and that is aft mount and thrust links. Purpose of this thrust links is to transfer the thrust load of the engine into the rear mount. And for sure you're not gonna find this kind of device on smaller engines like Leap 1, because on those smaller engines we are transferred this thrust power through the forward mount. So there you have it, there is your connection to 7/8. And with this last part we are done, so we can take a look on the model itself. And here we have it, 128 pages, and several hours later it is finally assembled, so I can show you how it looks, how it works, and what I like on it and what I don't like, of course, on it. First, let me show you the function of this model. In the control module you can find battery, through which, as you already saw, it can be powered. So when you put the toggle switch up, it will start to run. There is another possibility, thanks to this USB-A cable. You will plug it here on the back of the control box. And from now on, the base is charged, and as well you can power it from that base. So let me show you again. By switching toggle up, you will power it from the battery. Whenever you put toggle down, now it is powered from the grid. So you have always two different possibilities. Then controls, you have a throttle lever, and whenever you will push it forward, you will raise the speed. The engine will spin faster. Same way when you retract it, it will slow down. It has also sound. I don't like it, but I can show you. It's like a loop. And again, and again. And when you throttle up, all what will change, it will be just louder. So Yes, you have that option, but I like it more this way when it's quiet. The next thing which I would like to show you is clutch. When, for example, you want to rotate it freely, because now you have their resistance, as I mentioned before. Now you're rotating also that small DC motor here. So you need to disengage the clutch by pulling this lever, and then you pull the clutch out and the engine rotates freely. So you can rotate it as you want. And whenever you want to activate it, you again pull this lever, push the clutch in, and it is again connected. The DC motor is connected to the engine itself. When we look on the model, you really can see that there is a lot of details which I told you during assembly. I really like those windows, which you can remove like I did now here with the combustion chamber. This is the window which I remove out, and you have a nicer access or nicer view what is happening inside. Here you can see all stages of high pressure compressor, combustion chamber, and high and low pressure turbine. As I mentioned before, there is no chance to see low pressure compressor because it is inside of the intermediate case and inside of the fan case, of course. But I also told you that you can remove this top shroud, and thanks to that you get access to, let's say, intermediate case, and through that you can take a look inside and you will see the second stage of low pressure compressor. Another few details which I would like to mention are this fuel ramp and the fuel nozzles. This looks really cool, and my favorite part of it is this active clearance control of low pressure turbine. This looks really nice, thanks to this pipes, which looks almost the same like on the real engine. Then when we move up, yes, this thrust links, I explained you already during assembly that this is this part you can find on the 787. This way the thrust from the engine is transferred to the aft mount. On, for example, LEAP, the thrust is transferred from the forward mount, and forward mount you can find here on the core. It is installed the same way, but it will be over here. The aft mount is here only to carry the weight of the aft section, and of course helps to stabilize the engine or consume the motion forces. But here we have a forward mount up here on the case, and this is really a 7.8 design. So it is again a mixture of multiple engines, but I need to say it one more time. Nowhere in the manual or on the box is mentioned that it is some sort of real engine. It is DM119, and basically I always just compare it to the real engine so you can have a bigger picture how things works. And with this information we're moving to the next step, which I would like to mention, because thanks to this engine I think I was able to explain more or less the full function of the high bypass jet engine. And that is selling point of this model, because it almost looks like real thing. Last thing which I would like to talk about is price. The price of this model is $1,000. And yes, somebody might say, oh, that's too much. But compared to that one, that cost 250 euros. It's made out of plastic. That one, 250, same, made out of plastic. This one is completely made out of metal, and you can really feel it thanks to the weight and amount of the details which you can find on this engine. It's, from my point of view, it's worth. So if you want to make some aviation geek happy and you have a spare €1,000, this can be your choice. In the description below you can also find a link where you can buy this engine model, and next to it will be discount code Zeto, which will give you 15% off from any purchase on this page. And definitely take a look on this webpage. This is called Sterling Kit, and on that webpage you can find many other models, not only this one. They have piston engines, they have steam engines, they have all sorts of jet engines. So definitely take a look on their webpage, choose whichever suits you well, buy it, use my discount code, it will work on every engine. And with this information, I would like to say big thanks to Sterling Kit for providing this engine. And with this, we get to the end of this video. Thank you for your time. My name is Tomáš, this was a review with Zeto, and I will see you on next video. Bye.